Namaste, dear students. In this session of the Android programming course, we will learn about the SQLite database, its features, and key methods. The session outcomes are: at the end of the session, students will have knowledge about the SQLite database and how to implement the methods in the programming code. Firstly, let us understand what is actually the SQLite. SQLite is an open source, embedded, relational database management system designed in 2000. Open source means we don't need to make any payment or purchase this particular tool for developing software applications which require database support. It is embedded means we don't need to install it or set it up explicitly. And relational database management means the data are related, or what we call as the representation of table. SQLite is a lightweight database, which means it requires less hardware resources with zero configuration. We don't need to configure the SQLite. So installation is very simple. No requirements of a server or installation. Generally, the DBMS require server tools for executing the DBMS statements. Despite its simplicity, it is laden with popular features of DBMS. Though the SQL is very lightweight and very simple with no configuration, but still it has all the popular features of DBMS which we see in other DBMS tools. The SQLite supports standard relations database features like SQL syntax, the SQL transactions, database transactions, and SQL statements. SQLite is considerably the lighter version of SQL database, where most of the SQL commands don't run on SQLite database. Once SQLite is in place, it is important to ensure that a feature or command is available in SQLite. Only then can it be executed. SQLite is a compact library. With all features enabled, the library size can be less than 600 kilobytes. Depending on the target platform and compiler optimization settings. Normally, the available DBMS tools require considerable amount of memory and other hardware resources. If we compare the other DBMS tools, the DBMS servers and SQLite, the SQLite requires very less amount of memory. It's not even 1 MB. So this will have a very great impact on the performance, on the execution of SQL statements. SQLite is an embedded SQL database engine. Unlike most other SQL databases, SQLite doesn't have a separate server process. SQLite reads and writes directly to ordinary disk files. SQLite is an in-process library that implements a self-contained serverless, zero configuration, transactional SQL database engine. Now let us see the features of SQLite. The database transactions are atomic, consistent, isolated, and durable, what we call in simpler terms ACID, even after system crashes and power failures. Zero configuration means no need to set up or specify the configuration details. The administration is not needed. Full-featured SQL implementation with advanced capabilities like partial indexes, indexes on expressions, JSON, common table expressions, and window functions. A complete database is stored in a single cross-platform disk file. This is a great advantage. The database stored in the form of file can be accessed across all other platforms. Great for use as an application file format. So this type of specification helps the software applications to easily communicate and access the database. SQLite supports terabyte-sized databases and gigabyte-sized strings and blobs. So we see in industry level applications or real life applications where we store huge amount of data, then database size goes in gigabyte and terabyte. So even such huge size databases are also supported by the SQLite. Small code footprint. As we just now discussed, the SQLite has less than 600 kilobyte fully configured or much less with optional features omitted. It is very simple and easy to use API. SQLite is fast. In some cases, it is faster than direct file system I/O. As it is written in ANSI C, the TCL bindings included bindings for dozens of other languages available separately. Well commented source code with 100% branch test coverage. So the coding done for the SQLite has a very detailed comment. And SQLite is available as a single ANSI source code file that is easy to compile and hence is easy to add into larger projects. It is self-contained, means no external dependencies, and it is a cross-platform, that is platform independent. The SQLite can work on all types of platforms or environments such as BSD, iOS, Linux, macOS, Solaris, VxWorks, Windows, etc. And even the databases created using SQLite are very easy to port to other systems. The sources are in the public domain. We can use the SQLite for any purpose: commercial, educational, entertainment, personal, etc. The SQLite comes with a standalone command line interface client that can be used to administer with SQL databases, SQLite databases. These are the advantages of using SQLite. It's a lightweight database, requires very little memory, automatically managed database, very reliable, no installation needed, and has a great performance. And where can we use the SQLite? Here are the suggested uses. It can be used for the Internet of Things, IoT, application file format, such as in with XML, JSON, CSV, etc. The SQLite can be used. And for the website databases, that is dynamic web applications, can make use of the SQLite. Stand in for an enterprise RDBMS. SQLite is often used as a surrogate for an enterprise RDBMS for demonstration purposes or for testing. And now let us see the situations where SQLite works well. The SQLite works well with the embedded devices and the Internet of Things, application file format, websites, and in the area of data analysis, server-side database. Moving, let us have the architecture of SQLite. At the core level, it has interface, SQL command, processor, and virtual machine. In the compiler part, it has the tokenizer, parser, and code generator. In the backend, the B-tree, pager, OS interface. SQLite also has accessories such as utilities and test code. It works by compiling SQL text into bytecode, then running that bytecode using a virtual machine. It has similar architecture like Java virtual machine. SQLite OS interface or VFS. The internal organization of the SQLite library can be viewed as a stack of modules shown to the right, which is shown in the image which is on our right hand side. The tokenizer, parser, and code generator components are used to process SQL statements and convert them into executable programs in a virtual machine language or bytecode. The database file and compile time options. The complete state of an SQL database is usually contained in a single file on disk called the main database file. During any SQL transactions, SQLite stores additional information in a second file called the rollback journal. Or if SQLite is in WAL mode, a write ahead log file. The compile time options are SQLite can be built just fine using the default compilation options. However, if required, the compile time options documented below can be used to omit SQLite features or to change the default values of some parameters. The virtual table mechanism of SQLite. A virtual table is any object that is registered with an open SQLite database connection. From the perspective of an SQL statement, the virtual table object looks like any other table or view. The virtual table mechanism allows an application to publish interfaces that are accessible from SQL statements as if they were tables. SQL statements can do almost anything to a virtual table that they can do to a real table, with the following exceptions. One cannot create a trigger on a virtual table. Trigger are some actions specified with a time, event, and triggers are not possible to be applied on virtual tables. One cannot create additional indices on a virtual table. One cannot run alter table, add column commands against a virtual table. Backward compatibility. File format changes in SQLite. The underlying file format for SQLite database doesn't change in incompatible ways. There are literally hundreds of billions, perhaps trillions of SQLite databases file in circulation, and the SQLite developers are committing to supporting those files for decades into the future. There have been enhancements to SQLite such that newer database files are unreadable by older versions of the SQLite library. But the most recent versions of the SQLite library should be able to read and write any older SQLite databases file without any problems, which simply means in software engineering and with respect to the software applications, the software re-engineering. So the backward compatibility is almost similar to the software re-engineering with respect to the databases. Now let's have some multiple choice questions. First question is SQLite is a option A NoSQL database, option B distributed database management system, option C relational database management system, option D operational database management system. And the correct answer is option C relational database management system or DBMS. Second question is SQLite is written in option A C++, option B C, option C Java, option D Python. And the correct answer is option B. The SQLite is written in C programming language. Next question. SQL is an in-process library that implements a. Options are option A self-contained, option B serverless, option C zero configuration, and option D all of the above. And the correct answer is option D all of the above. Fourth question, is SQLite case sensitive? Option A true, option B false, option C neither true nor false, option D none of the above. And the correct answer is option A true. And these are the references for the further study. Thank you.